Good morning, everybody. I'm sorry I can't be in school today. I have jury duty. So I wanted to teach you lesson 10-1. So please take out your notes packet and look at lesson number 1. So the first thing that we're going to talk about today is what it means to be a standard position angle. So an angle is said to be drawn in standard position if its vertex is at the origin and its initial ray points along the positive x-axis. So when you draw an angle in standard position, what you want to remember is that your initial side is always going to be drawn on the positive x-axis here. And your vertex is always going to be 0, 0. We're going to talk about this arrow in red in a minute. This part here, the ending side of your angle, is called the terminal side. This red arrow is just showing the way that your angle is rotated. Okay, so when you're drawing an angle, you have to look at your angle measurement to see if it's positive or negative. If your angle is positive, it's telling you that you're rotating counterclockwise. So what that means is that your vertex is 0, 0, you're starting at your initial side here, and to get to your terminal side, you're rotating in a counterclockwise direction. In other words, your arrow is pointing up. That's a positive angle. If your angle is negative, your vertex is 0, 0, you're starting at your initial side, you're ending at your terminal side, but now your arrow is pointing down. So here we're rotating counterclockwise for a positive angle and clockwise for a negative angle. Now we're going to try to actually draw some angles and name what quadrant it's in. If you forgot about the quadrants, here's just a little refresher. So this is quadrant 1. Sometimes we use Roman numerals. This is quadrant 2, quadrant 3, and quadrant 4. Sometimes I remember that by thinking it's C for coordinate plane. If you were to draw the letter C, that's the order that the quadrants go in. 1, 2, 3, 4. Okay. So in order to draw your angles, you need to set up a set of axes. So I'm going to do that first. So set up 4 sets of axes here. Okay. So we're going to start with example 1, drawing an angle of 25 degrees. So the first thing that you want to think about is that when you're over here, my vertex is 0, 0. Here's my initial side. If I were to go all the way over here, this would be 90 degrees. Right? And if I were to keep going, each quadrant would be 90 degrees. So that's how I'm labeling this. So if I'm trying to draw an angle of 25 degrees, it's going to be maybe ending somewhere right here. And I want to show that since my angle is positive, I'm rotating counterclockwise. So this would be my angle right here of 25 degrees from here to there. If I were to draw an angle of 300 degrees, here I am, starting at my positive x-axis. starting at 0 degrees, this would be 90, 180, 270, 360. So when I draw my angle, I want to think, okay, I have to go past 90. Oops, let me use red. Past 90, past 180, past 270. And I'm going to end somewhere over here. So here's my angle. And it's a 300-degree angle. Okay, now let's talk about the third one, negative 105. So I'm starting at the vertex, 0, 0. My initial side is the positive x-axis, but now I'm rotating clockwise because my angle is negative. So here's 0, but then I'm rotating clockwise. So this would be negative 90, negative 180, negative 270, and negative 360. So I need to go negative 105. So let's see. So this would be negative 90, and I have to go a little bit more. So here I would be. This is negative 105 degrees. Okay, now let's try the last one. So my vertex is 0, 0. Here's my initial side. If I wanted to label my angles, I could. 0, 90, 180, 270, 360. Okay. So now, because 460 is more than 360, I know that I'm going to have to go around more than one time. So this is going to show me 360. Notice I didn't close in that circle there. That's showing me that motion in red, that diagram is showing that I went around one time, and now I need to go another 100 degrees because I'm at 360, so I need to go another 100. So it almost looks like a little bit of a shell. That's 460 degrees. Right, so looking at this, this is telling me that I went around the circle one time, or 360 degrees. And this is telling me that I went another 100. Okay, now let's go back and state what quadrant each angle terminates in. So this is my terminal side of my angle, and so that's quadrant 1. Here for example 2, this is my terminal side of my angle. That's quadrant 4. For example 3, here's my terminal side. That's quadrant 3. And for example 4, here's my terminal side. That's quadrant 2. Okay, so the next thing that we're going to talk about today are what are called reference angles. Before you figure out what your reference angle is, first you would need to draw the angle measurement that they give you. So let's start with that. So I'm going to set up my axes here, and I'm going to draw these 4 angles. So what I would like you to do is to pause the video and to draw in these 4 angles. Okay. So I'm starting by drawing an angle of 140 degrees. So here's my initial side. My angle's a positive angle, so I'm just going to some labeling here. And then I'm going to draw in my angle. So 140, so this would be 90. I'm going to end somewhere over here in quadrant 2. Just make that arrow look a little bit better. Okay. So here's my angle. They're telling me my angle is called theta, so I'm just gonna label it with a theta. Okay, now let's take a look at number 2. Here's my initial side. Add in my labeling, 0, 90, 180, 270, 360, and I'm gonna draw in my angle. So go past a little bit past 270, and here I am at 290, and again, I'm gonna label that angle theta. Okay, now let's look at our third. So now our angle is negative, so we're gonna be rotating clockwise. So we have 0, negative 90, negative 180, negative 270, and negative 360. So we're going negative 175. So this would be negative 90, and then negative 175 would be somewhere over here. I didn't quite get there. Make my arrow look a little bit better. Okay, I'll label that angle theta. And then our last one is 390, so that's more than 360. So we know we're going around our circle more than one time. So we have 0, 90, 180, 270, and 360. Okay, we're going counterclockwise because our angle is positive, so this would be 360. And then we have to go 30 more, so maybe somewhere over here. It's my terminal side. I'm going to label my angle theta. Okay. So now we're going to draw in the reference angle. So your reference angle, you're going to label with an X. And your reference angle is drawn from the terminal side of your angle to the x-axis. So the first thing that I'm going to do is I'm just going to use the highlighter. Maybe I'll use green. And I'm just going to highlight the terminal side of each of the angles that we drew. So here's the terminal side here, in example 1. Here's the terminal side here in example 2. Here's the terminal side here in example 3. And here's the terminal side here in example 4. Okay. So your reference angles is an angle that's formed between the terminal side of your original angle and the x-axis. Excuse me. Okay. So now I'm going to highlight the x-axis. If your angle is in quadrants 2 or 3, you're highlighting the negative x-axis. And if your angle is in quadrants 1 and 4, you're highlighting the positive x-axis. If you want to write that down, if your angle is in quadrants 2 or 3, I should say, if the terminal side of your angle is in quadrants 2 or 3, you're highlighting the negative x-axis. If the terminal side of your angle is in quadrants 1 or 4, that's the positive x-axis. So here I'm going to label that angle X that's highlighted in green. That's called your reference angle. Okay. The last part of the lesson today is converting from degrees to radians or radians to degrees. So a radian is a measure of an angle, a central angle, that intercepts an arc whose length is equal to the radius of a circle. So I do have a little demonstration about this that I'll show you tomorrow. But for now, I'm just going to show you how to convert. So the nice thing is that this conversion, converting from degrees to radians, is on your reference table, which I'll show you in a second. But the rule is you want to multiply by pi over 180. So if you go to your reference table and you look here, it will tell you that 1 degree is pi over 180 radians. So what you're doing is you're taking your degree measurement and you're multiplying by pi over 180. And again, I can explain why this is when I get back to class tomorrow. So if I have a 75 degree angle, it's really 75 over 1. If I multiply by pi over 180, I'm going to multiply across the top and the bottom. So I'm multiplying the top and I'm multiplying the bottom to get 75 pi divided by 180. That's my angle in radian measure. If I wanted to reduce that, I could. So if I went to my calculator, I'm just going to type in the 75 divided by 180, and then my calculator will reduce that for me. Clear out all my sigma stuff. If I make a fraction and I type 75 over 180, oh, yours should do it, but if you push math, enter, enter, it will show you. It's 5/12. So another way that I could write this is 5 pi over 12. So the calculator is just helping you to reduce. You would need to know that you would also need to include the pi in your answer. Okay, let's take a look at the second one. So 135 degrees, we want to express that in radian measure. So if I multiply by pi over 180, I'm going to multiply across the top and the bottom, so like this. I get 135 pi divided by 180. Again, if I wanted to reduce, I could go to my calculator and I could type 135 divided by 180 and your calculator should just give you the fraction. This calculator, I have to push math, enter, enter just to make it happen. So it's 3/4. So my answer is going to be 3/4 pi. And again, the calculator was giving me the 3/4. Okay. We can also convert from radians to degrees. Maybe I'll use a different color by multiplying by our angle in radian measure by 180 divided by pi. This conversion is also on your reference table. So if you have an angle in radians, you want to go to degrees, you multiply by 180 divided by pi. Keep doing it. Let's see. Okay. So here I'm going to multiply by 180 divided by pi. So I'm going to multiply across the top, and I'm going to multiply across the bottom. So negative 2 pi times 180 is negative 360 pi divided by 5 pi. And here, the pi's are just going to cancel, leaving me with negative 360 divided by 5. Which is going to give me negative 72. So negative 72 degrees. I looked at the second example, if I took 3/4 pi, or 3 pi over 4 is another way to say it, and I multiplied by 180 over pi. I'm going to multiply across the top. I'm going to multiply across the bottom. We get 3 times 180, which is 540 pi over 4 pi. Again, my pi's are going to cancel out because, and I get 540 divided by 4. Which is going to give me 135. So 135 degrees. This next one is a little tricky. I have 2 radians, so 2 radians. I'm multiplying by 180 divided by pi. So this time the pi's are not going to cancel out. I'm going to multiply across the top and the bottom. So I get 360 divided by pi. So it's 360 divided by pi degrees. If you wanted to see about what that is, if you went to your calculator and you typed in 360 divided by pi, it's going to tell you it's about 115 degrees. Okay. They also asked you here to draw a sketch of each angle. So now that we converted, I'm going to draw a sketch. I just realized I forgot to sketch the first couple too. So let's go back and we'll sketch all of them. So 75 degrees would be somewhere in quadrant 1, like this. 135 would be somewhere like that. -72. Remember now we're going clockwise. That 135 that 115 something like that. Okay, so there are some practice questions that you can try at the bottom of this lesson, and the answers to the practice will be posted on Canvas. I'll post it so that you can see it during class time. So please take a few minutes if you have some time at the end of class to try the practice questions, check your answers on Canvas. Homework tonight is number 1, and there'll be extra help on Tuesday morning this week instead of on Monday morning because I'm not going to be there on Monday. So if you have any questions, I'd be happy to go over at the beginning of class, or if you wanted to come in for extra help, I'll be there early tomorrow. And homework tonight is number 1.